let's look at the index and explore point-slope form a little more. So, here we see the general form y minus y1 equals m times x minus x1 for point-slope form. And you're actually going to see me add y1 to both sides. So when I work in point-slope form, I get y isolated, and I'm working with y equals the slope times x minus x1 plus y1. This is the form that I will use where I've added y1 to both sides. And that's the form I want you to practice using too. Okay, it says the equation of line F is 2x plus y equal 4. Well, let me get that into y equal mx plus b form. Let me subtract 2x from both sides. Y equals negative 2x, because we subtracted 2x, then plus 4. Okay. And now, if F is parallel to G, so parallel, that means same slope, so slope equal negative 2. So for G, we have y equals negative 2x plus b. We don't know the y-intercept yet, but we could substitute the coordinate 1, 4, 1 for x, 4 for y, and figure that out. But we're going to do something differently to get into point-slope form. It'll look something like this. Y equals slope of negative 2 times x minus, I'm going to leave this blank, and then this is either going to be plus or minus a number here for my y1. So we'll think of this as x1, y1. So that means x1 is coming inside the parentheses. This is x1. We wrote that up here. And x1 is 1. So we're moving to x equal 1 and y equal 4. Now, before we do anything else with this, you're going to see me drawing arrows all the time in point-slope form. And this tells me x minus 1 that I go right 1 unit, and plus 4 that I go up 1 unit. The plus 4 meaning up probably makes sense. X minus 1 going to the right maybe does not make a lot of sense. We'll keep practicing and you'll get used to it. Alright. G is perpendicular to H and passes through the point 2, 0. Okay, so we have G with y equal slope of negative 2. So for G, we have slope of negative 2. And then for H, we need to do the perpendicular slope. So like before, we need to flip this. 2 over 1 is now 1 over 2. And this negative is now positive. So this was for the slope of G, and now this for the slope of H, positive 1/2. Okay, so again, we have y equals 1/2 times, we have x minus x1, and then plus y1. So here, my x1 is x equal 2. So that's x minus 2. And then my y1 equals 0. So that would be like plus 0. Now, do we have to write plus 0? No, we don't. I'm going to write it this time, but we'll obviously get used to just not writing. And this says that I went right 2 units to x equal 2. This is y equals 1/2 times x minus 2. It would be very easy for you to put this into slope-intercept form. Okay, time to graph the lines. So we need F, we need G, and we need H. F at the top of the page. Y equal negative 2x plus 4. Okay, so negative 2x plus 4. Y-intercept at y equal 4. Then down 2 as I go right 1 for a slope of negative 2. Okay, so this brown line is F. Now G. What do I know about G? For G, I need to hit the coordinate 1, 4. And then I need to put a slope on of negative 2. So I'm going to go to 1, 4. 1, 4. Now I'm going to put a slope of negative 2 on. So that's down 2, right 1. Down 2, right 1. I don't need to plot all of these points because this is a straight line. So if I hit some of the points correctly with a straight edge, then I'm going to hit them all. And this violet colored thing is G. Finally, we need to graph H. Do H in this fabulous color called yellow-orange. So H says go through the coordinate 2, 0 with a slope of positive 1/2. So that's up 1, right 2. So we go to 2, 0. And that's here. We actually already hit that point on the F line. Now we're going to hit it again. And this time slope of positive 1/2. Up 1, right 2. And there's H. And there we've done the index. We've written lines in point slope form. Great job, Smarty Pants.